Hey, how's everybody doing out there? Hey, precalculus! Hey, how's everybody doing out there? It's a beautiful Thursday afternoon before spring break. Spring it is not today. So that's why you, yes you, the calculus student, is watching Channel 5B on Thursday afternoon to prepare you for the AP Calculus exam, which is an hour right now. Ah! Ah! Hello, kid. How many days? Is that 63 days? 56 days? 49, 42, 35, 28, 21, 7. Ah! Hey! So, who's out there? Call in 972-925-3123. Give us a call and we'll give you a question. Very exciting stuff. Do we have anybody out there? Hello? Hey, Scott?
It's me.
What you doing, man?
I'm trying to correct your grammar. I thought you were in charge of the PSAT program. And
Correct my grammar? What did I say?
You're like you, the calculus student. You is watching the AP calculus.
No. You can be singular or plural.
No.
Hey.
No. It's a collective. It's the calculus student.
You as a calculus student.
But you didn't say that. You said you is watching the calculus.
Don't argue with me, all right? What's going on?
Not much. Miss Harmon is saying she's smarter than you. And I told her that Hillcrest had more people pass the AP test, and she's like, nope, more than W.T. White.
Well, that's a valid point. That's a very valid concern. She had W.T. White had 32 students pass last year, the most in the history of the district.
Excellent.
Pretty impressive, don't you think?
Do we have a higher passing rate though?
I think it was about the same.
Oh.
We had 30. We had 30, and Elizabeth Hahn didn't show up, so it only shows 29, but actually we had 30, which is pretty exciting stuff.
Yeah.
Don't you think?
It's very exciting.
Well, I think you need a hard problem because you're being a little cantankerous this morning. Is that Kent in the background?
No, he's not here.
Who's there in the background?
Miss Podicary.
Miss Podicary? Hi, Miss Podicary.
Hi.
Scott! Hello?
Yes.
Can you see this problem?
A little bit.
Okay, you can't see it?
There it is. And we go over 8 to the EX over 1 plus e to the x. All right, hold on a second. U equals 1 plus e to the x.
So what are we going to do? What are we going to do, Scott?
U equals 1 plus e to the x.
Why is that, Scott?
I'm always thinking of you, Mr. Fleischer.
You're thinking of me, and that's sweet. Now, hey, Scott, you have a girlfriend, and this is a PG, this is a G-rated show. So go ahead.
All right, du equals e to the x.
Yep.
Dx.
Yep. So what are we gonna do from there?
I'll solve for dx. That's what I like to do.
Yeah, I like to do that too, Scott. That's amazing.
Dx equals du over e to the x.
Okay, what do we do? What do we do from there?
Du over, it's e to the x, 8e to the x.
Yeah.
Times du over e to the x.
Which the e to the x cancel out, so you just got the integral of 8 du over u, which is what?
Natural log of u!
Natural log of u! 1 plus e to the x, right. And let's not forget our little plus c for c go.
Where's my bell? Where's my bell?
What's that? You got there you go. Hey! Scott?
Yes.
Hey, call in again, all right?
I will.
Who's out there? Butters!
Yes?
Butters, you missed the problem of the week.
I know. No. The only problem, the only mistake I did, instead of plugging in 1 over 60, I plugged in 1.
Ah, so you actually had it, but part B was a little bit hard.
I know. I don't even know how to do it now.
Butters, at the end, if you stay till we're at 5 minutes, 5 to 5, we're going to go over it. Isn't that pretty exciting?
Yeah, I want to see that.
Make sure you call in and we'll go through it, all right?
Okay.
Butters, I'm going to give you a real hard problem.
No, give me some easy. Warm up.
A little warm up because you like butter. You like butter. Butterbean Love. You know who Butterbean Love is, Butters?
No.
He's a great basketball player for the Chicago Bulls in the early 70s. Bob Butterbean love? Check it out. All right?
Too long ago.
All right, here you go. Check this out.
But you just want me to integrate that?
Yeah.
Okay, let me think for a second.
Come on, Butters.
Hold on. People? Okay, that would be, let's use 2x as u.
Okay, you want u to be 2x? Uh-oh, we're in trouble, Butters.
I know we're in trouble. What are
You're
you
in
doing
trouble,
to me
Butters.
here?
Why are we in trouble?
Because we don't have the little chain out there.
You don't have the little thing out there?
Yeah, no chain out.
No chain out, okay. So what do we do from there?
I don't even know what you have to integrate to get tan.
Okay, you're right, because we can't integrate tangent, can we?
That's what I'm saying.
I know, you don't have to yell. Hey, Butters.
What?
When in doubt, if you can't, you know what? If you set u equals something and it doesn't work out,
I know.
you have to either simplify, expand, or change it somehow.
Oh yeah. Hold on.
Yeah.
Let me try.
Butters.
Sine over cosine.
Sine over cosine. That's it. Sine over cosine, Butters. Okay, now what do we do? What's u going to be equal to?
Let's use sine. Sine of 2x.
Try again.
My.
Well, if you said then your du is going to be on the bottom.
Oh, well, okay, then use cosine.
Yeah, okay, so if u is cosine 2x, what's du equal to?
Negative sine of 2x, negative 2 sine of 2x.
Negative 2 sine 2x, good, all right, and then what do we do from there?
We need a negative 2 there, on top. Negative 2 and a 1.
Well, tell me, I don't know how you do, tell me what to do, tell me what to write.
Okay, go up.
Go up.
Right there.
Uh-huh.
Put negative 1/2.
Negative 1/2.
And inside, negative 2.
Okay, I got you.
There we go.
All right, thank you for
So we
help.
have 1 over u du.
Okay, and what's the integral of du over u?
Natural log.
Natural log of u, baby!
Wow.
So it's natural log of cosine, absolute value cosine 2x plus c, right?
Yep, and you can put the power inside the natural log.
Inside? What do you mean?
Yeah, well, isn't that the power? Negative 1/2 is the power?
Well, yeah, it's natural log of cosine 2x raised to the negative 1/2 power. You can do that, but
yeah.
And so it'd be like 1 over the square root of natural log of all that stuff.
Yeah.
It looks fine the way it is.
Okay.
Hey, Butters, call in again. Good job.
Okay.
Hello?
Hey.
Is this LaKendra Ross?
Yeah.
Man, where have you been?
I've been around, just not calling in.
I got your picture here. Here's your picture. That's a wrong picture. Uh-huh. You've been around. Have you been, you hope you haven't been studying too much English there, Miss 730 verbal, whatever. Can we get a, it's a blurry, isn't it? There you go. Hey! All right. Hey, LaKendra. What'd you do in class today?
We didn't have class today.
Well, whenever I say that, like, what did you do last time you had class?
We started on growth and decay, separation of variables mostly.
Growth and decay?
Mm-hmm.
Man, that's hard.
But not the actual growth and decay stuff, just the separation of variables.
Just the separation of variables?
Yeah.
Okay, well, we'll go. Let's, here we go. You ready? Separation of variables, no problem. We're going to start out easy for you.
Alrighty.
If dy dx is equal to y times 1 plus sine of x, wait, hold on. Find y when x is equal to 0 and y is equal to 1. How's that?
Okay, first you're going to separate it. Move your dx over.
All right, very good. Get all the y, okay.
Then divide dy by y.
Right, get all your y's on one side, all your x's on the other side. Fine job, LaKendra, fine job. Keep going.
Then you're going to integrate both sides.
All right, what's the integral of dy over y?
Natural log of y.
She's on fire. Natural log of y, all right. What's the integral of 1 plus sine of x?
U equals... How? Oh, integrate 1 and it's x. And the derivative of, when you integrate sine x, you get negative cosine x.
Right, so what's the integral of 1?
X.
So it's x minus cosine x, right? Plus c. Okay,
Yeah.
now what do we do from here?
Then you e both sides.
So if we e both sides, what do you get?
You get y equals e to the x minus cosine x, and you can separate that into e
So it's
to the
e to the x minus
times-
cosine x plus c, okay?
Yeah, then you can separate it into,
But okay, keep going.
okay, e to the x times e to the cosine x.
So it's e to, okay.
Times negative
Well,
e to the cosine.
where is this going to come in? Where is this x equals 0, y equals 1? What are you going to do about that?
You can plug in 1 for y and 0 for x.
Okay, if we
To
plug
figure
in
out
one,
what
if
c
we
is.
plug in 1 for y and 0 for x, you know, what you did, you could plug it in down here, which is good. But Lakendra, you also could have plugged it in here if you wanted to, and I think it would work out fairly easily if you did that.
Okay.
But because this way, what's natural log of 1 equal
0.
to? So 0 is equal to 0 minus cosine of 0 plus c. And what's cosine of 0 equal
1.
to? So you got c is going to, it's 0 minus, c is going to be equal to 1.
1, yeah.
So if c is equal to 1, then you just got this plus 1 over here.
All right.
Okay? Now how can we simplify this? You're doing great. How can we simplify e to the x minus cosine x plus 1?
It's e to the x times e to the negative cosine x times e to the 1.
Right, but what is e? It's like, let me ask you a question. This is what's x to the a minus b? What is that equal to?
X divided by x to the a divided by b.
Right, divided by x to the b.
Yeah.
Right.
Uh-huh.
So you could simplify this to be e to the x
over
divided by e to the cosine
x.
x times
E to,
times e to the 1. Which
Yeah.
is e. You see that?
yeah.
Pretty exciting, don't you think?
Uh-huh.
I'm excited. Lakendra?
Uh-huh.
That doesn't take much.
Uh-huh.
All right. Hey,
All
call
right.
in again, all right?
Bye.
Christina!
Hola.
Hola to you.
What's up?
What's up, dude?
Hi, Mr. Fleischer.
Is that Rachel?
Yeah.
Yeah, I'll tell you. Hi, Rachel.
Hi.
Hi. Okay, Christy Knapp, if you're in trouble with this, Rachel says she knows the answer, so.
Okay.
All right,
Trouble, you know the answer.
No, she doesn't. Yeah, that's right. Egon, baby.
that's right.
What do you want to... Huh? What? You're not talking.
I want you to derive the top question.
Okay.
Why is he not talking?
I don't know either. Why is he talking?
Are you alive? Are we having
He's whispering.
Yeah, what are we doing?
Yeah, that's a good question.
Do this next one.
What?
What do we do?
Hold on. I'm thinking. Oh, cosine of ex, e to the x.
Okay, so therefore it's cosine e to the x times e to the x, right?
Uh-huh.
Okay, good. And so if that's the case, how does that help in here?
You put natural log of pi in for x.
So cosine times e to the natural log of pi
Uh-huh.
times e to the natural log of pi, which is equal to what?
Oh, it's cosine.
It's what?
Cosine of pi.
It's cosine of pi, which is equal to
Times-
what?
Oh. Isn't it cosine of pi times pi?
Cosine of pi times pi. What's cosine of pi?
-1.
Ding, 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 ding. -1. So the answer is negative pi, right?
Yeah.
Hey, Christy.
Uh-huh.
Fine job. Fine job.
Thank you.
No, thank you. Okay. Ben Wright,
Hey there.
what are you doing?
Oh,
What are you doing?
we're just sitting here, you know. Thought we'd call and say hi.
Oh, well, that's very nice of you. Let me, I have your picture. I'm looking for it over here.
Great.
Great.
Is it my picture or someone else's picture? Why don't you show a picture of old Mr. Irby over here too?
No, it's there's a picture of you in a very pensive pose.
Oh, really?
Hey, is there a reason why no one sits around you?
I smell bad, you know.
I mean, we're looking for people, but no. Hey, Ben? Ben, where
that?
you go to school next year?
We don't know yet.
We don't know? Do you have
I consider my mother and everyone else who asks a part of my team.
as a part of your team? Well, that's good. Hey, Ben?
Mm-hmm.
Ben?
Yes?
I'm going to give you some problems here. I want to know which of these 10, you got 10 here. Let me fold this over so they all fit. Which of these is equal to the natural log of 4? We'll go through them. Why don't you pick out 5 that you think you know the answer to. 5 of these. Which of these are equal to natural log of 4? Pick out 5 that you know the answer to, and you'll leave the next caller with the other 5. Which of these you think is equal to natural log of 4? Ben Wright, ladies and gentlemen. Benjamin Wright.
Is it?
Or you could say yes or no. Like if you know the answer is not one of them, let me know.
I believe 6 is.
6 is because e to the natural log of u is u, so this is a yes. Fine job, Benjamin. What about, now if you know one of them is not, you could say that also. Pick out one that you know is or is not.
I would say that 7 and 10 are.
7 and 10 are. Why are 7 and 10 are?
Because the ln of 1 is equal to 0.
Natural log of 1 is 0, right? Or you could say natural log of a minus natural log of b is natural log of a divided by b. So this is this is natural log of a times natural log of b is natural log of a times b. So therefore, even if you didn't know it was 0, if you knew your natural log rules, you're going to be natural log of 4. Okay, you got 2 more, Ben. Take it home. Take it home, Benjamin.
How about 3 and 8?
3 and 8. Why is 8 a yes?
Huh?
Why is 8 natural log of 4?
It's the natural log of 2 to the 2.
Natural log of 2 squared and 2 squared is 4. And what about 3? Why is 3 natural log of 4?
It's the natural log of 4 minus the natural log of 1.
Very good. But also by definition, the natural log of x, by definition, is equal to the integral from 1 to x of 1 over t dt. So therefore, by definition, the natural log of 4 is equal to the integral from 1 to 4, which you actually integrated in your head, and you knew that it was natural log of t. You plugged in 4 and subtracted and plugged in 1, or you could have looked at it by the definition.
Well, what can I say? I mean, I'm just a little jumpy today, you know?
Hey, you know what? I think that you did a fine job, Benjamin. Fine job.
Thanks.
And we're going to leave the next 5 for the next caller. Call it again. Call it again. All right.
Hello?
Hello?
Yeah, what's up?
Is this David Kent?
Yeah.
You didn't even answer. You didn't even try the question of the week last week.
What question? The one with the airplanes?
Yeah, was it a little too hard for you, David?
No, I was gone all of last week.
Oh, okay. So how did you know about the airplane ones then, huh?
Because I looked at it today.
Okay, and you had a little trouble then, huh?
Huh?
You had a little
No.
trouble there, huh, Kent? Huh?
It was easy.
Huh? I didn't see an answer.
That's because when I tried to answer it, it switched to the new question of the week.
Oh, okay. So, all right. You're right, though. But that's, hey, David?
What is that?
I have no idea. I don't do any of that stuff. Hey, David, well, answer the other 5.
The other 5 that are what?
Well, what is the answer? Do any of these, the other 5 are what? 1, 2, 4, 5, and 9. Hey, I'll tell you what, I'll just rewrite 9 over here.
Okay.
Tell me if this is equal to natural log of 4 or not. Which of these are and which of these are not?
Okay, 4 is.
4 is why?
Because it's a natural log of 8 over 2.
Right, very good. Natural log of 8 over 2. A fine job, Mr. Kent. Fine job. Okay.
9 is not.
Why is 9 not?
Because it's just like natural log of 8 divided by natural log of 2.
Well, how do you know that's not?
Because it has to be like...
Okay, all right, David. What does it simplify to?
What does it simplify to?
Yeah.
Hold on, I know this. Give me a hint. I don't think it does it. It's not the form. What does it simplify to?
3.
3?
Because
Wow.
natural log of 8 is natural log of 2 cubed.
Oh yeah. Okay. Of course, that makes sense.
That's right, of course. Hey, ladies and gentlemen, hey, this could give you inspiration because this gentleman got a 5 on the AB exam last year. So for any of you who think that you're having trouble, should give you some inspiration.
Thanks for using me as an example, Mr. Fletcher.
I know. Well, that's the abuse I took from you was minor. Hey, what about 1, 2, and 5?
1, 2, and 5.
Yeah.
See, number 1. Hold on. I can't read that.
It says the integral from 1 to 4 of e to the t dt.
Is that it's asking if that's the natural log of 4?
Yeah.
I don't think so.
Well, what does it equal then?
E to the 4th minus e.
Yeah, it's just the integral, right, it's just e to the 4th minus e to the 1, okay?
Yeah.
What about, let's skip number 2, what about number 5?
Number 5? I don't think so.
I don't think so either. Natural log of 4 would be, no, it's
something
not,
else.
okay? What about number 2? Now this is, I want you to give me the answer to this. This is a BC problem.
Yeah.
Because this is integration,
This is integration
by
by parts, right?
Right.
Okay.
What's the integral of natural log of t? You should probably just memorize that.
Wait, the integral of natural log of t?
Yeah, what's the integral of natural log of t?
T natural log of t?
T natural log of t minus t, I think. Because if you take the derivative of this, you
Yeah.
All right, so therefore, and then the answer would be 4 natural log of 4 minus 0 minus 1. So.
Right.
All right, David,
Yeah.
if you stay around the end of the show, it'll show you how to do that airplane problem. That you have so
I
much
know how to
trouble
do the
with.
airplane
Okay,
problem.
that's fine. You know what, David? Well, you know what? Here you go.
You gonna put me on the spot right now?
No. What I'm going to do is I'm going to put this up right now. In case for those who did not see the problem of the week last week, I will put it on the screen and.
So small.
Okay. It says at airplane at the beginning of an airstrap, it's 50 miles per hour. The plane lands at 50 miles per hour. The plane is decelerating directly proportional to time t.
A equals, should I tell it?
No. I want
Why
you to
not?
give me the answer.
Huh?
You have a half an hour left.
You already did it.
I'm about to go home.
What's the answer, David?
The answer? I don't know what the exact answer is. I
Okay,
know how to
that's
solve it, though.
all right, forget that. All right, we're going to go through it at the end of the show. All right, call in again. Good job, David. Good job.
All right, bye.
Bye. Who's this? Mondo's?
Mondos.
Hey, what are you doing?
What are you doing?
Man, I tell you now, I try to have a peaceful dinner, and I run
Hey.
into the great Antoy Preston.
Hey, man, your wife's pretty cute, man.
Hey, my wife is 5 months pregnant, so don't mess with her, okay? All right, I sure would appreciate it if you. All right, here you go. For those of you, Antoy, want how sad it was? It was our anniversary yesterday.
Oh, really?
Yeah, and we went out to dinner at a place that the gentleman who's on the phone was a waiter. I take my wife nothing to the finest restaurants up there.
Exactly, which is why I was there.
That's
You
right.
didn't even get my table measurement. You can look on the
I
map.
didn't even know you were there. Next time I'll ask.
Okay, I would hope so.
Okay, if 3x squared plus 2xy plus y squared equals 2, then the value of dy dx at x equals 1 is what?
Hold on, we're doing it on paper. Hold on real quick.
Okay.
Working it out. Okay, write this down. You ready?
I'm ready.
All right, 6x plus 2x,
Uh-huh.
parentheses 1, dy dx,
Okay.
close parentheses, y,
Plus y.
plus y, parentheses 2,
Uh-huh.
plus 2y dy dx
Uh-huh.
equals 0.
Equals 0. That's right. Okay.
And then we solve for dy dx, so hold on real quick.
Okay. You're doing a fine job, Antoy.
With everything else, everything that doesn't have dy dx on one side,
See.
move those on the other side.
Move everything that doesn't have dy dx on one side.
Okay. So I'll move the negative 6x and minus 2y. I'll move that to the other side, and that equals 2x dy dx plus 2y dy dx. And what do I do from here?
Okay, now factor. Factor to the dy dx.
So dy dx is equal to 2x plus 2y, which is equal to negative 6x minus 2y.
Now you divide by 2x plus 2y.
Okay, and then what do I do from here?
We'll plug in x equals 1, or 1 for the x's.
Well, if I plug in x equals 1,
oh, never mind. We got to do the y's. Hold on.
how do I find what y is?
Wait, what are we asking for again? Go up to the top.
I want to know what is dy dx when x is equal to 1.
Yeah, plug in the x's.
Plug in the x where?
In the formula, in the
Which one? This one?
No, plug in the top first.
in the top.
In the top, because
To get the y.
that will tell us what y is, right?
Exactly.
So it's 3 plus 2y plus y squared is equal to 2. Okay, how do I find y from there?
You factor.
All right, y squared plus 2y plus 1 is equal to 0.
So y plus 2y.
Y plus 1 squared is equal to 0, so y's got to equal -1.
So now you plug the 1 and -1 in for the dy dx. So that's -6 -6. Yeah. Wait, what? Yeah, -6 plus 2. And let's see, 2 plus -2.
So what's the answer?
That's not defined.
Because you got 0 on the bottom,
The
right?
0 on the bottom, yeah. So you can't. It's not defined.
Antoy, fine job. I think you should take a look at this, make sure. And you know, Samantha wanted
Mr. Reicher, can I get a bell? Oh, yeah, that's what I'm looking for.
Hey, Antoy, Samantha was really interested in knowing more about you, just to let you know, okay? All right.
Yeah, they don't realize how smart I am up there at Mondo's.
Well, I can't imagine why. Hey, listen, call in again. Great, it's good seeing you. I'll talk to you later.
All right.
Bye. Is this Kara Collier?
Hi, Mr. Fleischer.
How you doing?
All right.
How's your Honda?
Oh, it's great.
Have you crashed it at all?
No, not really.
Not one, not one dent?
No, it's great.
Kara, brand new car.
I know.
Where are you going to school next year?
I'm looking at TCU,
Hey, that's great. What are you going to major in math?
chemistry, pre-dental.
Hey, that's great. I know that I know Miss Blackwell has you studying hard for this test, right?
Mm-hmm.
And you are doing everything she asks, right?
Oh, yeah.
Okay, all right. Just want to make sure. Is that her in the background?
No, that's Portia.
Portia? Portia Williams?
No, Portia Barrett.
Oh, okay. Portia Williams is from Lincoln. Here you go. Here's Kara.
Okay, here we go.
Here we go. No pressure.
Oh, no. Okay.
Take your time.
Okay, so that'd be, cosine natural log of x times 1 over x.
Very good. Excellent.
Okay, so then we have natural log of e. Okay, cosine natural log of e to the pi times 1 over e to the pi. Okay, so then we have cosine of natural log of e to the pi. Okay, times 1 over e to the pi. So it'll be cosine of pi, which is -1 times 1 over. Oh, wait a minute.
Times 1 over what? Well, you did this cosine of pi, right, which is -1 times what?
Times 1 over e to the pi.
Very good.
Yay!
I mean, that is, you did that pretty easily. That wasn't that easy of a problem. Kara Collier. Hey, I need a picture. Where are those Carter Cowboys? I need some Carter Cowboy pictures.
Okay, I'll tell Miss Blackwell.
You tell her to take some pictures.
Okay.
All right. Hey, listen, call in again. Great job, Kara.
Thank you.
Nina! How we doing?
Fine.
Fine.
Yeah.
This is Nina Alvarez.
Yeah.
The only picture I have is with you and Misty.
Yeah. No.
That's a nice picture some guys from Skyline wanted to see.
That's all about Molina. Where's Misty? Yeah,
Nina?
where's Misty?
Where's Misty? Right here?
Yeah.
Who's that? Is that Ann in the background?
I think so, yeah.
You have a soccer ball on your head. Hey, growth and decay?
Yeah, I guess.
What do you mean you guess? You know what, Nina? You get a really hard problem for that.
Oh, man.
Yeah, here you go. This is going to look really easy, but it's not. I want you to solve for y.
you multiply by dt, and then you
Multiply
and then-
both sides by dt.
yeah,
okay.
and then you divide it by y plus 1.
Very good. That is awesome. You cannot stop Nina Alvarez. No matter how much you try, you can only hope to contain her.
And then you integrate both sides.
What's the integral of dy over y plus 1?
U equals y plus 1. And and the
Okay.
u equals dy. Like, it's going to be, you're going to have to do the natural log of u plus c.
Okay. So it's just, this is
it's
just,
going to be
if
the
you-
natural log of y plus 1.
right, natural log of y plus 1. What's the integral of dt? I'm losing my voice.
T.
Right, t plus c. Okay, here it goes. From here, what do we do from here?
E both sides.
E both sides. What's e to the natural log of y plus 1?
Y plus 1.
Okay, here you go. I want you to simplify this for me. What's e to the t plus c simplified?
E to the t times c.
It's
E to the t-
right,
oh, yeah.
because it's e to the t times e to the c, and
yeah.
what's e to the c equal
C.
to? You know what, Nina? You
Yeah.
cannot stop you. Can only hope to contain her.
And then you subtract by 1. And that's what y equals.
That is a fine job. Hey, Nina,
Yeah.
I think that you have to say this word. Hey, that's a great job. That's a really good job. Fine job. Nee from Skyline's waiting. He wanted to talk to you. Hey, Nee?
Yeah.
Nee,
Uh-huh.
that problem was pretty hard last week, wasn't it?
Did I miss it?
That problem last week was pretty hard,
I
wasn't
just
it?
worked on this morning.
Huh?
I just worked on it this morning.
Yeah, it's pretty hard. We're going to go over it before the end of the show.
Did I send it in?
You did, yeah. It wasn't, nobody got the correct answer. We're going to make this week's question a lot easier. Hey, Nee?
Yeah.
Here you go. Here's a fine question for you.
Write it down.
Hey, I can't see it. Somebody changed it. Okay. There you go. Okay, let me start. Just do the simple one. Alright, let's
I can't hear it.
substitute u equals t squared.
What's that?
Can't hear anything.
Well,
Okay.
you don't have to hear anything, you just have to see.
Okay. Well, I can't. Okay. All right, hold on. Oh. All right. Let's do one. Just do u equals t squared,
Okay, u is equal to t squared.
and then du is equal to 2t
du is equal to t dt, okay?
Uh-oh. I know we're gonna draw.
Keep going. Hey, Nee? Nee, Annalisa from Brian Adams just called in, said she wants to do this problem. So call in again on the next problem, okay? But she's going to show you how to do it, all right?
All right.
Okay. Annalisa?
I don't want it.
Annalisa?
What?
It's a happy face.
Woo!
You know, Annalisa, I see a little too much shoulder there.
That's not funny.
It's a little funny.
Son.
It's a little funny. You can't help it.
No, don't do that.
Annalisa, what am I going to set u equal to if this is not right?
1 over t.
Okay, and then what's du equal to?
Negative t to the something. Negative 2.
Right, because this is really t to the negative 1, so it's negative t to the negative 2, which is negative 1 over t squared dt. Hey, you know what? And this is for Nee also. You know how you can always tell about 95% of the time, whenever you just have an integral formula, like you know the integral of cosine, you know the integral of sine. If what you know the integral of, if you have the argument, usually set that equal to u, and it works out. Annalisa? So what do I do from here?
You have to make, what? You have to add a negative on the, do that. No, and then do your little SE.
My little
Integration.
My little Essie.
And then it's the cosine of u over du.
Why is Rachel laughing?
That's not Rachel.
Okay.
That's somebody else.
It's negative cosine of u du. What's the integral of cosine of u?
Wait.
No.
I thought it was over. Okay, I'm sorry.
It's not, because, see, it cancels out. See, this right here is negative du. If this is du, this is negative du.
Uh-huh.
So what's the integral of cosine u?
I think Annalisa needs some inspiration.
Negative sine u. Wait, no, sine u? I don't... Sine u?
I didn't mean to do that. I'm sorry. Is it sine or negative?
Sine. Just regular.
Lazy.
It's regular? Get down! Get down! Get down with the bad self. Okay.
So white, Mr. Fleischer.
Rachel. This is, I am not, okay, anyway.
You are white.
Hey,
Okay, now you plug in your...
so the answer is negative sine of 1 over t, right?
Mm-hmm.
Make sure you take a look at that and make
Hey,
sure
she
it
wants
makes
a
sense.
smiley face.
You want a smiley face? Okay. There it is. All right. Hey, Annalisa?
Mm-hmm.
Call in again, all right? Does a fine job. Ooh, sorry.
Mm-hmm. Goodbye.
Josh Newton,
Yes.
how come you didn't try the question of the week last week?
I didn't have time.
Was Kyle afraid of the question of the week?
I don't know.
I think Kyle was a little scared, wasn't he?
And I noticed last week you didn't know what my name was.
Josh Newton?
You put John.
I know who you are.
But you put John.
Well, that was just a mental error. Okay, hey, Josh, you heard it from you. Let's try this, Josh.
Okay.
Josh, I do certainly know who you are. Is Kyle there? Because I got a problem for him.
No, Kyle hasn't stayed after today.
Oh, he's a little afraid, isn't he?
I don't know where he is. I haven't seen him.
He's a little scared.
I don't know about that. Well, that's gonna you have an inner derivative there.
I know it's an antiderivative.
No, it's an 1 over x is the inner derivative of natural log.
So what's the answer?
The answer?
What's the answer to this problem without writing anything down?
Without writing anything down. It's going to be the sine of the natural log of x.
Very good. Excellent job. Sine of natural log of x plus c. That's a great job, because u is going to be equal to natural log of x, and du is going to be equal to 1 over x, right?
Mm-hmm.
And so it's just the integral of cosine u, which is sine of u, right?
Yeah.
Hey, Josh, I'm losing my voice.
Okay.
I haven't lost my voice in 7 years of doing this.
Okay.
Very sad. It's your fault.
It's my fault?
It is, because you criticized me and how I spelled your name.
Oh, okay.
Hey, call in again. I got a real good problem for you next time, a much harder problem.
Okay.
Okay. Is this Matthew Amend?
Matt, yeah, what's going on?
What's going on, Mr. Amend?
Not too much. What's going on with you?
I'm losing my voice.
Yeah, that's right.
I'm
What?
losing my voice.
Oh, you are?
I got so excited with Butters and Butterbean Love that... Yeah. Anyway, hey, Matt.
Yeah.
You go by Matt or Matthew?
Matt.
Okay.
Matt Plumley. They said to tell you my name is Plumley. I don't know why.
Do you know Do you know Matthew Amend?
Mm-hmm.
Okay. Is he in calculus?
I think so.
All right. Mr. Plumley?
Can you give me a growth and decay?
A growth and decay? Yeah. I'll give you something similar to a growth and decay.
Okay. Miss Harmon wanted me to ask for it.
Well, how about this? I'm going to see if we could do this part first.
Okay. Is that 4 plus x?
Yes, sir.
Okay, let's see.
I'm sorry, this should be t squared, though.
All right, you put the dt on the other side, multiply it through by dt.
We'll get to... Go ahead.
And now you Multiply through by 2y. Divide by 2y, I mean. Can you push it up some?
Yes, I can.
There you
Thank you.
All right, let's see. Now you integrate both sides.
What's the integral of dy over 2y?
Natural log of 2y. Natural log of 2y, yeah.
What's the derivative of natural log of 2y?
dy over u over u prime, which is u prime over u, which is dy over 2. Oh no. Shoot.
So what's the integral of dy over 2y? You know the derivative. You know it's not. You know this isn't right because the derivative of this is 2 over 2y, which doesn't match up.
Mm-hmm.
So
you put the 2 on the other side. Put it back on the other side.
you want the 2 on the other. Okay. So we'll make it dy over y is equal to dt over 4 plus t squared, which is natural log of y, is equal to what? How do you integrate that?
Arctan.
Arctan of what?
Arctan of shoot.
1 over
Put the 2 outside and do the integral. Does that say plus?
Yeah, it
t
says
squared?
plus t squared.
All right. So you put the 2 outside.
Okay.
Over 2 arctan of t over 2.
Okay, because a is equal to u is equal t, so it's the arctan of u over a, which is t over 2, times 1 over a, which is 2 over 2. So it just comes out to be arctan or inverse tangent of t over 2. And if we wanted to plus c, if we wanted to solve for y, what would we do?
E both sides.
Okay, and what do I get?
Y equals e to the tan of, all that stuff. Oh yeah, and then you put the c out front.
Right. Do you understand why we put the c out front?
Yeah.
Because e to the c is just another c, right?
So they're just the same, it's just a constant, so you just put it out front.
Matthew?
Yes, sir.
Fine job.
Can I have another one? Thank you very much.
Hey, that's a great job. Hey.
Oh yeah, Susanna says hi to Anna.
Who?
Anna from another school. Susanna says hi. I don't know.
Anna says hi to Anna?
No, Susanna says hi to Anna.
Susanna says hi to Anna?
Yep.
Okay. And if you want to ask if you want to ask Anna the prom or something, we could do that also.
Oh, okay. All right. Sounds
anyway,
good.
all right.
All right. Thanks a lot.
Thank you. Portia!
Yes?
Portia! My voice. Portia?
Huh?
Are you nervous?
Uh-huh.
I am too, so that's okay. Are you from the Great Carter Cowboys?
Yes.
Do you know that, are you doing everything Miss Blackwell tells you to do?
No.
I'll tell you. Okay, here, we'll give you a nice derivative problem. If f of x is natural log a cubed of x squared, what's f prime of x and what's f prime of e?
Hold on. It'll be, your u is x squared.
Okay.
I'm sorry, your u is natural log.
Well, one thing I want to do, whenever you see this with trig functions or natural log functions, rewrite the whole thing to look like this.
Okay.
Okay, always, because it shouldn't be there. It's meant to be quantifiable. So if this is f of x, now what is f prime of x?
6x.
6x.
Uh-huh.
Okay.
6x times the natural log of x squared. Yeah, put parentheses around it. And square the outside.
Okay, and the reason why is that you skipped a step, but that's great, because it's 3 times all that, natural log of x squared, quantity squared, times the derivative of what's inside. And what's the derivative of natural log of x squared?
2x, yeah.
2x divided by what?
X squared.
Right, so it's 3 times 2x, which is 6x, so it's all that divided by x squared, which is equal to 6 natural log of x squared, quantity squared, all over x. You sort of see that? See, what you do is, it's 3 times natural log of x squared, quantity squared, times the derivative of what's inside. And the derivative of what's inside is 2x divided by x squared. Because the derivative of natural log of x squared is the derivative of u all over u.
Okay.
Okay, and the way I simplified it was, I took this and did this, because it's just 3 times 2x, and then I canceled out one of the x's.
All right.
All right? Now, if that's the case, what's f prime of e? If this is f prime of x, what's f prime of e?
It'll be, you sub in E.
Okay? And what's the natural log of e squared equal to?
2.
Very good. So it's 2 squared, which is 4, so the answer is 24 over e, right?
Uh-huh.
Hey, Portia, great job. Fine job, Portia. Cabo. Great job. Hey, Judith?
Yes.
Hey, did they ever get the check straight with you?
Oh, wow, oh my gosh.
What?
Yes, it did.
Well, why'd you say, oh my God?
Because I didn't think I don't know.
You're the great Judith Hernandez, and I know that it was Judith and Judith. That was the problem, is that on the roll that one of the teachers sent, they misspelled the name, and that was why there were 2 different checks. And then we had to reissue it, but I'm just glad that Mr. Huggins took care of it for you.
Thank you. I appreciate that.
You're welcome. You ready for you want an easy or a hard problem?
Okay, it's my first time calling, so can you please give me an easy problem?
Medium?
No, you didn't hear that.
Hey, I'm trying to think if I have your picture here. Hold on.
You do. Try to guess.
Oh, there you are. You're right by. Okay, I see.
Oh, there.
You're next to Jamil, right?
Somebody. Yeah. That's us.
That's pretty exciting.
There's my sister.
What's that?
There's my sister Ruthie.
Oh, your sister's Ruth?
No, well, and my brother Twan.
Well, that's pretty exciting. Since it's your first time calling, we won't hurt you too bad, okay?
Okay, I trust you.
You trust me? Oh my gosh.
I mean, of course.
Okay, well that puts too much pressure on me. So I gotta give you. Here you go. What's that? Real quick.
2e raised to 2x.
Okay, and if that's the case, what's f prime of natural log of 3?
2 times. Hold on. 2 times 3. 2 times 2 times 3. Am I right? Yeah.
2 times e to the 2 natural log of 3. Right? How do you simplify this? I want this whole thing simplified to one normal integer, or one integer.
12.
12. What's 2 natural log of 3 equal to? How do you
okay, hold on. Oh, it's 3 squared.
Right, so it's 2 times e to the natural log of 9, and what's e to the natural log of 9 equal to?
2 times. Wait, 2 times 9, which is 18.
Right. See, that wasn't so bad, right?
Thank you. Hold on, look, listen to this, okay? We have our own bell, because you never give us a bell.
Skyline. Hey, you know what? Why? Because Francisco's waiting. He's at Skyline, and he's calling from another room. Why don't you help? Okay. Hey, listen, hey, Judith does a great job.
Okay, thank you.
We'll see you soon, okay?
Uh-huh.
Hey, Francisco!
Yeah.
You know what? I got a really hard problem. You ready for it?
Yeah.
It's really hard. Here you go. It is. Matter of fact, it's the hardest problem we've asked in a while, but you are the great Francisco Hernandez, and this looks a lot easier than it is. See if anybody out there could get this.
Arc speaking.
What?
Arc speaking.
Nope.
No. Okay. When you factor out that, I mean, 1 over square root of x.
What's that?
1 over square root of x plus x square root of x.
Well, you want me to multiply this through?
Yeah.
No, that's not going to work. Try
Okay.
and turn down your TV a little bit. Take your time. First of all, this is a lot of pressure. This would, I think, when I saw this, it took me about 4 or 5 minutes to figure out. But so you were closer when you first instinctively said arcsecant. If I'm going to give you what u is equal to, and I'm going to tell you what the u is in this problem, and see if you can figure it out. If u is equal to square root of x, what does this look like? It's confusing. Actually, this may make it more confusing than it is.
Crystal Boston, please report to the main office. Crystal Boston, please report to the main office.
Okay. Du equals 1 over 2.
Okay, du is equal 1 over 2 square root of x. Very good. Okay, how does that help us? Francisco?
We can solve for dx.
Okay, we solve for dx, we get dx is equal to square root of x du. Okay, now, where does that leave us? What is, in terms of u, what is this?
1 plus u squared.
1 plus u squared, very good. So this turns out to be 2 times du over 1 plus u squared. Do you see that?
Yeah.
And what's the integral of du over 1 plus u squared? Right, so it's 2 times arctangent of square root of x plus c. Pretty hard problem, isn't it?
Yeah.
You know what, and the thing is, it was just so hard to recognize, but you did a great job. Your first instinct of thinking it was arcsecant was right on, because it looked, even if it looks like anything, it looks like arcsecant, and you instinctively already thought that, and that was a great job. Francisco, call in again, all right?
Okay.
Hey, Justin?
Yep.
What you doing, buddy?
Not much.
Here is a fine problem. How come you didn't answer the calculus question of the week last week?
I didn't know there was a calculus question of the
Every
week.
week, $10 prize, $100 drawing for all the people who ever get it right.
I was lying, but oh well.
Oh, you were lying. Okay. All right. So,
All right. Looking at this one. Okay. Let's see.
no GTE.
1 plus ln of x, okay, take that to the top.
Take it to the top?
Yeah, well,
I don't know what that means.
I pull out the 3, and then 1 plus the natural log of x to the negative 1 times the natural log of x dx.
Wait, you lost me. So it's 3 times 1 plus natural log of x to the negative 1?
Yeah, times 1 over x.
Times 1 over x?
Yeah.
Okay.
And then you've got it right there.
I got it?
Yeah, it'd be 3 times the natural log of 1 plus natural log of x plus c.
Well, that's great. And you do it in your head, which is very impressive because you recognize a form and you're able to get the answer, which is extremely impressive. But what I was hoping you'd set u equal 1 plus natural log of x, and the fact that you can do it like that is more impressive than anything. So you realize this is just 3 times du all over u,
right?
Which is 3 natural log of u.
Right.
Justin, that is a great job. Great job. Hey, Justin?
Yep.
going to keep you on the line. We're going to go over the question of the week. Nobody got the question of the week last week, so we're going to go over it. And we're going to show you this week's question of the week. It'll be it's a lot easier than last week. First of all, last week, I'm going to try to do this as best I can here. It says an airplane lands at the beginning of an airstrip at 50 miles per hour. The plane is decelerating directly proportional to time t. In part A, it says that the plane comes to a complete stop at the end of the airstrip in 1 minute. How long is the airstrip? This is a total distance problem.
Mm-hmm.
There's a total distance problem. And the way to do this, we'll do it step by step, is that the acceleration is directly proportional to time t.
Right.
So you had to know that. So to get the velocity, you integrate, which is negative t squared divided by 2 plus c.
Okay.
Because it's just a constant, and you integrate.
Yeah.
We know that at 0 seconds, the plane is going at 50 miles per hour.
Okay, so solve for C.
So we solve for c, and c becomes 50.
Right.
So now our equation is now negative kt squared divided by 2 plus 50. Now here's the hard part. It said that, Justin, in 1 minute, the plane comes to a complete stop.
Mm-hmm.
So we know that in 1 minute, and this answer will be up on the website, in 1 minute, the velocity, the v of 1 over 60, which is in terms of hours, is equal to 0.
Okay.
So you just plug 1 over 60 in for t, and then you solve for k.
Okay.
So now your answer, when you solve for k, that allowed you to solve for k. In 1 minute, the velocity was 0, which turns out to be this. And then all you do from there is you just integrate from 0 to 1/60th, and then you can do that on the calculator. You get 5/9 of a mile. Multiply that times 5,280, and you get that in terms of feet.
That makes perfect sense, but going through a problem like that, you must be assuming that I'm Kyle, and I'm not. But I did understand that. But Kyle's right here, and he's got some problem for you.
We're not going to have time, but tell him next time we get, because part B, which Kyle couldn't get, nobody got on the website, I need to go over because it's a really hard problem. In fact, I gave this to a bunch of calculus teachers, and it was everybody struggled.
Oh, okay. Well, he's offended. He's hurt.
Okay, well, he should have got this problem right. If the landing strip is a half mile, and this is on the website, so I expect you to, how long does a plane have to stop before going past the airstrip? How long does a plane have? Well, and once again, I'm going to go through this quickly, but the answer is on the website, so please take a look at it. Anyways, we're going to try to go through this quickly. Basically, it's the same velocity function, but q is going to be the time we're looking for.
Mm-hmm.
When the time that it elapsed, then we know the velocity is 0. And then from there, we just solve for k. And this is going to be pretty tough to explain. You're going to have to look on the website. But the point is, then we'll integrate. This is from 0 to q. We'll integrate it, and we'll be able to get our time. The point is that take a look at the questions and take a look at the answer on the website and go over it with your teachers, okay?
Will do.
The website, if you want to remember just one more time, and the question this week is a lot easier. I think even Kyle can handle it this week. www.apstrategies.org.
All right, man.
And the question of the week, which you'll see, is a lot easier this week. It says that the second derivative is e to the x cosine x. That's the second derivative, and I ask you a bunch of questions. If you have a function that's the second derivative, I ask you a bunch of questions from there.
Oh, okay.
So everybody who answers that question next and during the show after spring break we'll have a drawing for it. And like I said, hopefully Kyle will be able to answer this one. Right?
Kyle's really mad at you right now. I'd watch out.
Hey, I'm ready for him. I'll take him on anytime. Listen, y'all have a great spring break. We'll see you in 2 weeks, okay?
Okay.
Have a good one.
Bye.